All right, so here's part B of lesson 8. So it's page 2. We did the video for page 1. Here's page 2. So at the top here, you're going to write the equation for exponential growth or decay. So pause the video and see if you remember. So if you remember, it's a times b to the x, where a is the initial value and b is the growth factor. Sometimes we call it the growth rate. Either one is acceptable. The initial value is also the y-intercept. It's what y equals when x is 0. And when b is greater than 1, this is an example of exponential growth. And when b is in between 0 and 1, this is an example of exponential decay. Oops. So for this table, we're going to start with a bank account that has $700, and we're going to complete the table and make equations for all these different scenarios. So here we have a situation where we have a 30% yearly growth rate, so really high yearly growth. And we know in math that we have to convert percents to decimals when we work with them. So we're going to move the decimal 2 times to the left, and that's going to be 0.30. And then the growth, and then this is the same, but it's percent decrease, so this is also going to be 0.30 converted to a decimal. Now the growth factor, as we saw on the other page, we need to, if it's increasing, we need to add 1 to the percent increase. So our growth factor is going to be 1.03, or 103%, right? So our equation is going to be y equals 700, because that's our starting amount, times b, our growth factor, is 1.03 to the x. We could also instead do a parentheses for our multiplication. Either is acceptable. Now when it's a decay, we have to subtract the percent decrease from 1. So it's 1 minus 0.3, which is 0.7. So that means each year your bank account would only have 70% of what it had the year before. It'd be going down by 30% each year. So this part of the equation is similar, same initial value, but then our growth rate is going to be less than 1. So when the growth rate is between 0 and 1, it's exponential decay. So that makes sense. Our amount's going to go down. So you're going to complete the table here, right? And remember, each time you have to move the decimal place 2 times to the left. For increase, you're going to have to add, 0.02, right? And then you're going to write the equation. This one's a little tricky here. It's a very small percentage. But we still have to move the decimal place 2 times to the left. So it's 0.0004. And this line is increase. Right, so it's going to be 1.0004 as our growth rate. Okay. This one's a little interesting. 100% increase. So 100% written as a decimal is just 1.0. So it's an increase. So that's going to be 1, like all of these, plus 1.0, or 1, equals 2. So our growth rate is 2 for this one. So we've seen this before when it's a whole number. So that means your bank account is doubling each year. It's a growth rate of 2. It's increasing by 100% each year. You're adding the same amount of what it was worth that year to it to get to the next year. So you'll fill out the rest of this box. And then down here, you have some things to fill out. So the first one is done for you. We have a description. Now we're starting with $100. And in this first row, we're looking at the scenario, what happens if it doubles every year? Well, that would be growth, right? And our growth rate, you would see that here, the 2, it doubles. So that's just like this one up here, where it was 100% increase. 100% increase is the same as doubling. Okay, how about this one? Increases by 5% every year. So it's increases, so we know it's growth. And we know it's going to be y equals 100, our initial value, and it increases by 5%. So we know from this table up here, to get the growth rate, we have to add 1 to it. 1 plus 0.05, right? We have to convert this 5% to a decimal. We could write it like that, or we could write it like y equals 100 times 1.05 to the x. Okay, so for this one, you're going to have to work backwards. Notice here, the growth rate is less than 1. If it's less than 1, that's decay. Now so it's 97%, so we have to think, well, 97% is 1 minus what is 97%? That would be 3%, so this would be decreasing by 3% every year, right? Because 97 is 1.0 minus 1.03, or 0.03. That would be our growth rate. Okay, so you're going to try these ones. This one's a little tricky. Retains 63% each year. So if it retains, that means it keeps 53%, 63% each year. How much does it lose? How much lost each year? So you're going to have to think of percentages. This last one here, these are actually part of the at a loss worksheet that we did in class. So you could do that worksheet and then fill in the equations here and here.